with fabrics. I am Gilberto, I am the founder of Smartex. We started this company 5 years ago, but the growth has been massive. We are now more than 100 engineers working just in fabrics production, AI technologies. We have more than 10 countries where we deploy thousands of systems. I'm going to explain you exactly. And we raised $45 million of funding. This is an expensive industry to transform. And more, when I see like technologies for textiles, it's like, wow, this will take a lot of time and money because this industry is very complex. I'm going to show some examples here, but just to give you this quick overview. So fabrics. Everybody here that's bought fabrics at a garment factory, or if you want a fashion brand, if you are a buyer, purchaser, you know the nightmares, right? Some delays, some defects, the colors doesn't match, then the fabrics arrives at the garment houses a bit late, and then you delay, and then you have fines and discounts and all that stuff. So I'm sure some of these pains here was already felt by people in the audience, I'm sure. And when we talk about defects in particular, which is a topic that is very near to my heart, because 15 years ago, I used to be a textile quality inspection operator, which is horrible and very difficult job to do. So defects are a particular pain in my heart that generate delays, wasted days, no visibility over them, and so on and so forth. And the thing is, most of these problems, they start in the knitting mills or at the yarn level, and they get propagated and accumulated through the patching, to the dyeing, and they get all to the cutting tables, sometimes even to the garments, right? And we created some systems like 4-point systems and things like that to tolerate them and to pass them away. But we are basically lying to each other, right? We need to catch the problems in the beginning as possible of the process. So today I'm going to show you here some factories in Europe and Turkey are already using it. This is not a project, right? We have now 100 customers. So this is the factory of the future. They don't have any more people on the phones calling their knitters and their weavers like, hey, how is my fabrics? Please don't delay again. No. We are now presenting this solution, which is a PO tracking solution and a quality tracking solution. So imagine you have your order in your knitters or dyers or weavers, and you can see how many meters were produced for you. A bit like the Uber driver, you know, the Uber app where you see the car coming to you. And then you can also see quality alerts, how many meters of defects are coming to you, so you can optimize your cutting plans and things like that. But in order to build this amazing future, there is a lot of pain underground. We need to install internet in the factories. We need to install hardware. We need to train teams. So just to give you a glance of Smartex, we are 100 engineers, but most of us, we are in the streets, in the wild, installing cables, routers, access points, equipping machines with cameras and sensors. So this is very important, otherwise we can be here talking about data, AI, or blockchain, but none of that matters if you don't have like hardware there collecting data, right? What's the point of having blockchain if everything is on pen and paper today, right? So let's understand a bit like the origin of this problem and the big size of the pain, especially for garmenters that I have seen in the last few years. We created this tolerance in the row level. We call it 4-point system tolerance. But all of these defects, they arrive at the garment cutting. And what you see in the left-hand side of this slide is a classic cutting panel rejection because of fabrics defects you see over there, needle lines, sinker marks, and some other problems. So we created a system where we accept tolerances. And garment factories, they buy a buffer, they buy an extra fabrics because they know that some bad stuff will happen. This is an example of a big client we have in Bangladesh. They have their daily reports and their monthly reports, and look at this. They have 10%, 9%, 8% defect rate, but the rejection rate is almost zero, right? Because they just reject when it is really a big accident. So we created these systems to pass it by. Let's be honest, everybody produces defects, it's a normal thing, it's part of the process, it's part of the yarn, it's part of all the industry. So let's not be ashamed of admitting that there are problems with fabrics. And when we talk with knitting mills, they usually say that they have a 0.1, 0.5% defect. They actually mean rejection, right? And the dyeing, they present like a 1 to 3, sometimes 5%. But as I was showing you in the other slide, this is a classic rejection rate in the cutting panel, of garments cutting panel. And here you can see 3%, 2%, and sometimes you have big spikes, 27%, you know, sinker mark, patai effects, things like that. Let's put a finger here. When it goes to the panel cutting, it can be already too late, and especially if it goes to the garments. Here we see rejection rates of 5%, 10%, or even more. And if it goes to the garments, then damages the relationships with the buyers. We work a lot with fashion brands, PVH, H&M, and like this is a topic every day. They have the merchandising team always calling the fabric, the factories because of this. So it is a pain, let's admit it, and everybody here is part of the problem, and we can also be part of the solution, right? So, how can we stop this before, and why these defects were not stopped before? So, I have been traveling the world in the last 7 years in this company. All of these pictures are taken from my phone. And we are here in this amazing conference and an amazing organization to talk about robotics and AI and automation, but let's be honest. 99% of the factories when we go in the world, like, this is not happening, right? It's pen and paper, it's human labor, it's like, this is the reality out there. So, it's particularly in quality control, and again, I still have a fear of this because it was my first job. I used to be that guy on the slide. It's really difficult to have people inspecting fabrics, right? After 15 minutes, everybody is blind. And then you have pen and paper quality control, pen and paper, like defect reporting, so it makes it impossible for us to track the origin of the problems. And also the traceability is mostly done handwriting in the textile rolls. So if after 2 months you receive a complaint from H&M about some defects in the fabrics, you're like finding who was the operator, what was the needle that you were using, or what was the oil of that machine. It's impossible to track that. It's very difficult. Yeah? So this is what we are already implementing in manufacturers in Europe, is a PO tracking and a quality tracking, and I'm going to show you what are the stepping stones for us to achieve this. They have multiple solutions. The solution number one that we are implementing is inside knitting machines, or circular knitting machines, we install cameras, photo cameras, high resolution, like 9 or 10 cameras, and they inspect in UV lights, in infrared lights, in white lights. So it's a very complex problem. Actually, someone was saying that, I think it was the commissioner, you were saying that we need to have cameras to inspect this. It might be easier. I also thought so. And when I raised my first $1 million, I thought it was going to be enough to solve this problem. But then you have textile complexity. You have slub yarns, you have jacquards, you have irregularities that sometimes are defects, sometimes are not defects. On Mondays, they want to produce it like that. On Tuesdays, that's an injection. So it becomes really complex, and despite we already invested a few years in there, I think we are 90%, 95%, it's still not perfect. But we are going to get there. So you see stuff like that, like jacquards, where you have needle patterns, but then if a needle is bended, you need to detect it, or tiny lycra jumps that are just visible if the fabric is very relaxed, or sometimes after dyeing, or some yarn contaminations that are invisible to the human eye at the knitting level, and they will become visible after dyeing and finishing. Oil spots, all sorts of stuff. I could be here the whole day speaking about defects, but I don't want to bother you much with this. Then, all of these photos, we collect them, we process them with artificial intelligence, and we detect which type of defects we are talking about. Is it a needle, sinker mark, or is it yarn related, lycra related? All of this is to create a roll digital map. So what you see in the slide is a digital twin of the roll, where you can see the coordinates, the meters, the positions of the products, and all of this is integrated with the factory systems. So we can actually know which machines, which operator, which circumstances led to that defect. We do also roll grading and so on. So that all of this is stored online as well. So for the panels, when we spread the rolls, instead of having long defects, or many defects that will damage many panels, we will basically stop the machine in real time, we will alert the operator, and we make these defects much smaller. So we damage less panels. Okay. Basically, normally when we install our cameras, we wait a few weeks just to watch how the factory works, and the average defect length is like 20 meters, 10 meters, 30 meters. And basically when we implement our cameras, we stop it right away, so it's like 1 or 2 meters of defects. That's why we avoid worst. And many people ask me, Gilberto, why 2 meters? I want 2 centimeters, because I want it to be closer and not have... That's a good suggestion. I don't want to bother you with many videos on circular knitting machines, but the short answer is, if you put cameras or inspection on the top of the machine, the fabric is very stretched, and you don't see all the defects there, basically. There are some elasticity defects, tension defects. So, I'm sorry, it's a bit more expensive, it's a bit more complex, but at least we solve the whole problem by having high-resolution cameras in the bottom where the fabric is more relaxed. You see in the right-hand side of this slide, the comparison. In the bottom you can see lycra or elasticity defects, and in the bottom and in the top you don't see it. Then, this also has a massive impact to inspection people, because after knitting we usually have inspection operators and inspection machines. And now this is a great example of AI empowering workers, because all the workers, they were like, no, we are going to be replaced with this technology. No. Actually, this guy in the picture is in Turkey. This guy is doing his job 10 times faster. So we are empowering this guy to be much better operator. So he's inspecting rolls digitally. In 30 seconds, he can inspect a full roll. And then when he sees a grade B or a grade D, then he picks up that roll and goes to the inspection table and inspects it manually. So this is not about replacing people, but really to empower people to be much faster. Also, we can argue that I don't think anyone likes to work in the quality control machine, so we are kind of making this guy also a bit happier. All right, what does this mean to garment factories and to fashion brands, where usually bigger amounts of money and profit and pain is? If we stop all the problems in the beginning, we should have less problems in the end, right? So in the beginning, at the knitting level, we talk about $3 per kilo or $4 per kilo. It's not much, and people usually ignore wastage over there. So they pass it to the front, after dyeing and after finishing, and then at the garment level, if you have a problem there, or a delay there, you might have your order cancelled by the buyers, or you need to give a discount to the buyer, or you need to replace something, reproduce something in the back. So it's a big pain at the end. So let's solve the problem at the beginning, or even at the yarn level, as my previous speaker mentioned as well. And this is just an example. This is a garment factory in Europe that produces a lot of t-shirts to Hugo Boss. And they decided to do a comparison. They started buying fabrics from Smartex machines, or machines that have these camera systems. And they started comparing face-to-face Smartex fabrics with no Smartex fabrics. This is just an example that they agreed with me to share. They didn't allow me to share many others, but this is a small order of just 500 or 600 t-shirts, and they bought 50-50% garments, percent fabrics with Smartex and without Smartex. So you see at the top in the blue box, they cut almost 300 t-shirts in the first panel, in the first batch of rolls, and in the second one they cut 260 t-shirts. So much less t-shirts because the defects are shorter, so they damage less panels, right? This means a cost per garment just in the fabrics level of 3 cents. If you look to the little graph in the bottom right, you see that there was also a massive reduction of kilos from knitting to dyeing, non-fabrics, non-Smartex fabrics, because they just found a huge sinker mark in the dyeing process and they rejected the full roll. So just to give you some examples of how this can be impactful to garment factories. This is another example from another garment factory. Long story short, in the top they rejected 9 pieces. This is also a very expensive menswear, boxers, small panels to cut, but they rejected 9 versus 49, okay? Because the defects are small. This is the type of examples that we are catching up. We have many more examples that we are publishing soon, so if you guys follow us on LinkedIn or on the social media, stay tuned, because we are doing massive POCs with H&M and with Zara. H&M is actually doing it in Bangladesh with one of our customers, Fakir Fashion. But the long story short is garments will also become cheap, like 3 cents, 5 cents, sometimes even 10 cents, depends on the size of the garments. So now we are talking about real money for factories that produce millions of garments or hundreds of millions of garments per year. Then, solution number 2, now we talk about the cameras and the inspection and like stopping the machines. This is very like in the machine level. Solution number 2 is, how can I prove that these fabrics comes from that supplier, or there is no outsourcer, or they are using the Smartex systems. Maybe they can be saying that they have 100% inspection, but everybody is lying to each other and nobody really knows if the fabrics is actually 100% inspected and pure, right? So we started developing together with partners tracking systems with QR codes that avoids handwriting and gets all the information of the machine attached to the roll. So when I see a textile roll with one of these tags, I scan it with my phone and I see immediately how many defects is inside. What's the grading of this roll? Which machines, which factories has this roll coming through? Which dye house it went through? Things like that. These are indestructible tags. It's impossible to remove them. Even after dyeing and washing and reprocessing and re-dyeing, they always remain there. So this is the basis for a digital product passport, textile sell rolls, right? And instead of handwriting in the fabrics, now we just stamp it with heat press, and all the data from the cameras, from the machine, from the ERPs will speak with that roll. Now imagine for a garment guy that is receiving the rolls, he can just double check quickly, just scanning a roll and seeing how many defects are inside, and he can optimize the cutting based on that as well. Okay? Solution number 3, to be announced in the next few months, we are very proud of being working on this for almost 1 year now, is finished fabrics inspection systems. Many companies tried, many companies came to the space, but I don't think anyone invested $50 million in this problem, or so much time, or so much money, because it's really a complex problem. It's a more complex problem than it looks, and this is going to be announced over the next year, February, March, and we are looking for the first partners, also here in India, to be our first beta clients. So if you guys are interested or know anyone that wants to be the first crazy Indian company to partner with us on this project, we already have a few clients for Turkey, for Bangladesh, and Portugal as well. So India can be the next one. So in general, the ecosystem that we are building is not just about defects, it's not just about cameras, right? We have a very complex industry. The textile industry is so complex, right? In the food industry, you might have the farmer, the distributor, and the supermarket, right? For textiles, you have like 20 people to build a t-shirt, right? So it's so complex, and our vision and our mission is to connect all of these players, to connect the knitting and the weaving machines with the inspection machines, with the stampers, the batching, the compactors, eventually to the cutting tables. So we can see, like when you order an Uber, you can see how your car is coming, something like that, but in the supply chain, make it much more efficient and digitized. Okay? So, as I was telling you in the beginning, the growth has been massive in the last few years, meaning that we are doing something right. The Indian flag is not with the right color. I'm sorry about that. This is but I'm very proud to announce that we are now opening in India. We got almost 1 year in a bit of bureaucracy and certifications to import our systems to India. It was a bit painful, but now we are officially here, and we are also very proud about the sustainability results of our systems, because we save fabrics, we save water, we save energy, and more buyers like H&M, Inditex, or Google Boss, they look at these metrics and they really like to reduce their footprint also using these metrics. We have already a first success story in Singapore. It's a company called BS Apparels. Finishing. And if you guys want, we are also happy to do demonstrations there. Anyway, just to finish, now we arrived. We are very happy to partner with Indian universities, with textile institutes. We do that for every country we go. We partner with local companies, we partner with technology companies. Sometimes we acquire as well teams in universities or students, internships. And we are actively hiring as well in India for customer success positions and some engineering positions. So if you know any young, crazy guy that wants to join our team, or old as well, just needs to be a bit crazy, we are actively hiring and we want to partner, and wish to have a successful business in India. So thank you so much.